Hey Jenny, I just want to walk through this example in section 2.1 so that you have a little bit of an idea of what we talked about in class. We did a couple activities in the notes and you can see those online, but I think what's more important is just kind of getting down to it. So basically what we're doing is we're trying to set up the ability to create what we call a frequency distribution. And I'm looking at example 1 where we have a bunch of scores from a test. And so we want to basically create what we call a histogram. And so a frequency histogram basically looks like this, where you have a bunch of bars next to each other that kind of display the data. So as we get ready to set that up, I want to show you kind of how we do that. And so the very first thing we start with here is what we call the class width. And so in order to do that, what we do is we look at the highest and the lowest scores. So I'm looking here at 89 and 20, right? And in this particular case, they asked us to use 5 different classes. Classes are basically just groups. That's the best way to think about it. So the class width would be nothing more than 89 minus 20 divided by 5. Now the key here is when we go to figure that out, we would get 13.8. Now, no matter what, we're always going to round up. So always round up. Just kind of keep that in mind. So that means our class width is going to be 14 in this problem, right? Now, what that allows us to do is set the groups. So what we would say is, we have the first class would have a lower limit of 20, that's the lowest score, and then the next group would start at 34 because that's 14 higher, and then 48 and 62 and so on and so forth. Okay. What's also important is where the first category stops and the next category begins. So the first category would end at 33. Now, we had some discussion in class about this. Technically, that is 14 numbers. 33 minus 20 is 13, I get that. But if you actually count it on your hands from 20 to 33, that's actually 14 numbers. So it goes in line with our class width. So then we'd go to 47, here we go to 61, 75, and so on and so forth. There's one class on here I can't seem to fit, so that'd be 76 to 89. Now what we do then is we tally the frequency of all the test scores. So our first class, which is the 20 to 33 class, right, if I kind of just tally these up, 20 occurs, right, so I tally that once, 33 would fall in that category, and 25. So I have a total of 3 tallies there. Okay, let's go to the 34 to 47 class. Let's see. So I get a 45 there and a 44. So I'm looking at 2. Then 48 to 61. So 52 would count. 48 to 61. That would count. 61 would certainly count. 48 would count, and 58 would count. So we have a tally of 4 there. Then we go to the next class, 62 to 75. So 65 counts, 72 counts, and 75 counts. And you can tell then in the last class, now we're by process of elimination, we have 1, 2, 3 scores left. And so that's kind of how we begin to set our frequency distribution. Now, let's take a look at what we do with all that, right? So just going back to our classes from before, we had 20 to 33. This is example 2 now. 34 to 47, 48 to 61. Okay, and our frequency was 3, 2, 4. Now, before we go to put these on a histogram, we need the midpoint. And the midpoint is literally the direct center of each class. So in order to do that, for instance, you would do like 33 plus 20 divided by 2. And that actually winds up being 26.5. Now the great thing about this is we don't have to do this 5 times, because remember the class width was 14. So if I add 14 to 26.5, I'll get the midpoint of the next class, and so on and so forth. So this one would be 54.5. This one would be 68.5. 82.5. Now you say, well, why do we need to know that kind of stuff, right? So here's the deal, because when you go to set up your histogram, what you're actually going to put on the x-axis here would be, some tick marks, and those tick marks would be the midpoints. So like this would be 26.5, this would be 40.5, and so on and so forth. Wow, this pen is not really writing very well. Okay, and so just as an idea of how the bars would look, just to give you an idea, okay, the frequency of that first class was 3, so the first bar spans the midpoint, and that's how we create that first bar. And then the next one would look like this, and then you go all the way up to 4 here, right? And so this is how you actually create a histogram from scratch. Now, what we learned in class was sometimes a frequency histogram can be misleading. So we are going to look at what we call relative frequency. Relative frequency is the amount of times a class occurs relative to the total. So there were 15, I don't know if you noticed, but if you add up these frequencies, there were 15 scores total. So the relative frequency of how often somebody scored in the 20 to 33 range would be 3 over 15, or 0.2. And as we continue to do this, so these would all be 0.2 as well because they have the same frequency, right? Sometimes you get wacky decimals. So for the 34 to 47 range, 2 divided by 15 is about 0.13. Now what we have to be careful about here is that we round appropriately, because the total frequencies needs to equal 1 or 100%. So that kind of forces our hand here, and this is going to have to be 0.27. Now somebody asked in class, can I round this to 0.14? Sure, then you got to do this to 0.26. So you just have to make these work together here, right? And then finally we have a cumulative frequency column, which is basically a running, think of this as like a running total. Okay, what does that mean? That means as of right now I have only 3 test scores in. Add that in the next row to the 2 test scores that came in this group, and now I have a running total of 5. Add that to the 4 that came in now, and I have a running total of 9, so on and so forth, right? What's important is that when you get down here to this last cumulative number, that needs to be the total number of data entries that you had. So this is kind of like a self-check mechanism. If that's not 15, then what that really means is you probably tallied wrong when you were doing your frequencies. So let's kind of take that then and show you, well, what would we do here? Well, what we might do is we might form another histogram, right? Our first one was 26.5, then we had 40.5, right? So on and so forth. And this histogram might be just of the relative frequencies. So 0.1, 0.2, 0.3, 0.4. And so sometimes what happens is we form a histogram just off of the relative frequencies, and that gives us sometimes a better indicator of what's really happening. So I would say 0.13 is right around there, 0.27 maybe is like right around here. Just kind of guesstimating here a little bit, and then these were equal. So again, maybe there's no difference here, but sometimes it's a little bit more representative of the data, so we want to be able to adjust to both. So I hope this video helped you with 2.1, and we'll get you something for 2.2 should we need it as well. So let's just start with that. Try the I would say try the homework, which is the last 3 problems, or you can even try the you try, which I'll post online as soon as we're done with it in class. Just a quick note about the homework. I had to make a couple adjustments in problem 1. What we decided as a class, I didn't actually give you how many classes to use there, and that's kind of important. So what we decided making sure I'm telling you the right thing here. Yeah, problem 1, we're going to use 4 classes as you're doing your with, and problem 2, we're going to use 5 classes, 5 groups. So just kind of take note of that.